My second experiment in Java programming lab is using Java arrays. The topic using arrays. So my first experiment is ascending descending. So as you can see over here in Eclipse, I have the ascending descending program. So as you can see, there's a class ascending descending, and in the main function, I'm asking the user to enter the size of the array, and it's storing it into size. And after this, I'm creating an array. So an array is created like this in Java. We would write arrays in brackets equals to new. We need to allocate a memory for that and int the size and the size. So this is how the syntax is. And then I'm getting the elements using a for loop. I'm assigning the variables into the array of I, which is this one I created here. And then to make it into ascending order, we need to sort the array first. So generally we won't be sorting the array as in when we input, we will be just writing random numbers here and there. So once we sort it, we can get the ascending order. So as you can see in this for loop, there's two for loops for the row. Sorry, not for the row, but we need two for loops so that we can compare two elements. So what this for loop is going to do is it's going to compare first element with the second, like that, third, then so on, so forth. So it compares all the elements, and if it is less, it will swap. If it is less, it will swap into the first. If it is less, it will swap using a temporary swapping. So the temporary is into array I, that is given to array of j, and this array of I, which is going to j, is given to temp, and that is stored in j. So what this does is a swap function. No, sorry, swap uh, loop or condition, and after that I can print the ascending order, and the descending order is just the opposite. I just need to print them in the opposite order. So I would just made a for loop, and just it starts from the end, so it's size minus 1 and less than the size, and I minus minus, this will print the descending order of the array. So let's run the program. Enter the size, write 5, enter the elements 9, 5, 6, 8, 8, 78, sorry. Alright. As you can see, the array in ascending order is from small to big, and from descending order is big to small. And yeah, so that's my descending program, ascending descending program. Then the next um, program is to find the transpose of a 3 into 3 matrix. And um, so in this is a class transpose, and there's a main function. So I'm creating an array, two-dimensional array, as you can see here. So this is the syntax: int array 2 and new int the size, and I'm entering the elements into matrix. This for the for loop, and this for the row. This for the row, this for the column, and it's storing the values which I'm entering into this array of ij. So what a transpose of a matrix is, um, basically a transpose is when the row and column is interchanged. So what I need to do is to interchange the row and column. So what I did here is, in this for loop, when I'm printing, I just interchanged the row and column. So suppose I was row and j was column. I just interchange that, and I just printed it using this for loop, and I'll get the matrix. So let's see the program. Enter the elements of the matrix. Let's write 1, 2, 3, 4, 5, 6, 7, 8, 9. So as you can see, it's a 3 by 3 matrix, so it will take 9 variables, and as you can see, the transpose is over here. And so it's just that the row and column got interchanged. I just inputted the elements, and using in the loop for the transpose, I just interchanged the row and column. Okay, so my next program is just a linear search program to find element using linear search. So I just asked how many elements do you want, and made the user get the array. So all these um, inputs are stored into this array, which is created over here, and then I'm displaying the array over here just so that the user knows where the position is. And then enter the element, and I'm making variable key. All right. So uh, that element which I want to search is stored into a key. So in this for loop, I'm just checking using linear search if that key, when the for loop goes from 0, 1 to 3, if the key equals to that variable in that, then just return it, or return the index actually. So if you can see, it's just returning the index plus I. So the element will be found in that index. So let's run, and I'll just write 4 and enter the elements 1, 2, 3, 4, and enter the element. Let's just write 4. As you can see, the element is index 3, 0, 1, 2, 3. So it's right, and that's the program. Now it is unique and duplicate elements, which is a fourth program. So in this, the same thing to enter elements and just make the array basically. So I'm storing into array all the site and elements, and so that's a new array. And then to find the unique element, I need to check um, if that array of I is not, like, it's not repeating again. So it's so to do that, first I'll create the two loops, alright, to check both the conditions. Now I should make sure that array of I never, not array of I, but I and j, which is independent variables, should not be equal to each other, because if it becomes equal to, it will take that condition many times, and we'll get a lot of unique elements. It will be repeated. So we should make sure it never repeats. So inside this, suppose when this condition is fulfilled, it should check whether that never repeats. So if that repeats, suppose if there's two elements which are repeating, then the flag is set as 1, and if it's 0, the count is plus, so it displays the count. And also when it's 1, it will just print the array, the element. And for unique elements, it's just the same. It's just that I should be equal to j. Before it was not equal to, here it's equal to, so, and j should be one step ahead of I. And after that, it will just store this thing into temporary, which the one which is equal, and it will just print. So let's see the how many elements. Okay, 4. How many element? 1, 2, 3, 4, 4. All right. So okay, so I'll give another input for 1, 2, 2, 3. All right. So as you can see, unique elements are 1 and 3, and repeated is 2, which I repeated over here 2 times. So that is it. That is the end of the second experiment.